Hello and welcome to another one of D's ADD videos. Today we're going to look at double integrals to find area. Area can be the double integral of dy dx or double integral of dx to y. When you're doing a double integral, you work your way from the inner integral out to the outer integral. So you would, in this case, do dy first, and then you would do the dx. And then in this scenario, you would first do dx and then do the dy. If you're integrating with respect to y, treat x as a constant. And if you're integrating with respect to x, treat y as a constant. And once you get done, you're going to have bounds here. You're going to plug in, and then you work with the outer equation. Some scenarios, dy dx will be more beneficial. Other scenarios, dx dy will be more beneficial, but most of the time I'll just use dy dx because the equations will be given to you in terms of y equals. I will use another video to take time to explain the preference over dy dx versus dx dy. So I will leave that topic for now and move on. Just know that I will mostly use dy dx because most functions are in the terms of y equals. Alright, so how would I go about doing these double integrals? Well, when I'm setting up a double integral, what I try to do is I try to imagine myself inside the region of interest. So here's a small portrait of me inside the region of interest. But if I look up, what happens? If I look down, what happens? Well, when I look up, I hit this line here. When I look down, I hit this function here, x squared. So, depending on whether I'm doing dy dx or dx dy, I either look up and down or left and right. In this scenario, what I'm going to be doing is if I look above and below, that means I'm using dy dx, and for the inner bound of the double integral for that dy dx, I would have to have two functions. Inside is always a function. Okay? These are equations of a line. Depending on which scenario you're doing, dx dy or dy dx, you will either look above or below if you're doing dy dx, and we're talking for the inner integral here on both of these, and you're going to look for left or right. So quick side note here, this is one of the scenarios where it'd be better to do dy dx because the right side changes on us. It goes from the line to the x squared function. So to avoid having to deal with two double integrals, we would do dy dx, and I'll go over that again in a different video. The outer integral, when you're doing a double integral, whatever it is, dy dx, so you've already done this part of it, that's gone. Now we're dealing with the outer part of it. So when you're doing that, we have the smallest and the largest value. So in this case, if we're doing dy dx, it would be an x value here. If we're doing dx dy, it'd be a y value, numerical values. So again, the inner integral is an equation, and these are numbers. Now sometimes you might see numbers here, but don't forget that horizontal lines, the equation is y equals a number, and for a vertical line, it's x equals a number. So you might see, if you have flat lines as your function, a numerical value, even though I'm telling you equations here. So I wanted to clarify that out. So this is just the concept. Make sure that you have the fundamentals of doing a double integral. Make sure you check out the basic examples. There will be some basic examples on just how to do a double integral, and then there will be some on how to use it for the application of area. So check those out. Practice, practice, practice. Thank you and have a nice day.